And he's going to introduce himself because he's a mystery man, at least to some of us.
Where are the slides here? The slides are on Frank's slides. Oh, cool. Okay. Do they just come up?
So they're going to switch.
Yeah. Well, I guess until they get that up, I'll just talk.
Here it is.
Okay, cool. So I'm going to talk about what we're doing on the inside because we consider the outside pretty much done. We only have a few things left to basically use Facebook on 100% IPv6 only with no translation, no NAT. We'll probably launch that here in the next month or two. We'll be more or less done, I hope. It's mainly a time issue, not a technical issue at this point. But internally is where our motivations are right now, and we'll talk a little bit about that. And people ask, why would you do it on the inside? And it's pretty simple. We ran out of RFC 1918 space, and we'll talk about that in another slide. I also like to say that maintaining two stacks is pretty difficult. And some people argue, oh, you can put v6 on your edge and then just run v4 internally. That's a little short-sighted because if any of you are carrying around these little phones, it's only a matter of time before the CPUs and these things are running on the servers. And then instead of having 40, 80, or a small number of machines in a rack, you're looking at hundreds, maybe even thousands of nodes in a rack. And how are you going to actually address every single one of those? And by tackling the v6 issue today, we're actually going to future-proof our own abilities to get done. And again, it's also easier to handle one protocol as your primary and then have a tertiary, a secondary protocol on the outside. And as I said, someday there's also the big problem of technical bloat. We are a relatively young company. We just celebrated our 10-year birthday, and we still have a lot of IPv4 technical debt. And working through that is pretty difficult. And the longer you delay just means more work you're going to have to do in the future. And then also, there's a lot of industries, vendors, whatever, they'll say, oh, we support IPv6. No, they don't. They say they do, but they never test it. They don't QA it. And even if they give you something that works this month, their next code drop more than likely breaks something. So by basically saying nothing inside of our data center can run IPv4, you're forcing people that want to do business with us to support IPv6. So I'll talk about just really roughly how 16 million addresses wasn't enough for us. So we deploy everything is a layer 3 network. So our racks are routed /24. This is pretty simple because, hey, it's a well-known subnet. It's really easy. The math is simple. It's pretty simple. Everybody knows the subnet for it. You don't have to sit there and do a little bit of math on your fingers. It does waste a lot of space. You get 254. We use 80 in a rack. We could have renumbered, but really a 25 was all we could renumber to, so it's not really enough. And I like to say, use this method if you actually want to get to IPv6. And again, solutions. We could have renumbered. Again, we have a lot of code that assumes a rack is a 24. And now we would have to have code, on our existing IPv4 network think, oh, well, is this rack a 25 or a 24 or whatever subnet we chose? And, you're basically breaking your existing production network, your existing deployment tools, your existing, infrastructure. And that's actually, I think, harder than, using IPv6. And again, a 25 doesn't solve. So we looked at IPv6 as something as like a brand new network on top of our existing network. So it's something that you can just deploy, and it doesn't break anything usually because nobody's using it. So if it only really starts to break if you start using it. And most importantly, you can iterate on a brand new network, you can't iterate on your existing production network, because when you break things, Facebook is down and the world notices. Every time we have an outage, just go look at Twitter and it's like Facebook is down. So let's talk about IPv6 and how our standard allocation is a 32 and how hopefully 79 quintillion addresses is enough. Again, we do a rack on a /64. We're a layer 3 routed network. This is actually really important. Flat layer 2 networks really need to die. Mainly, especially in the v6 world, you don't want your core of your network to be handling neighbor discovery and tracking all the hardware addresses of machines on your network. It's much better to just have it all localized to the rack and protect the main part of your network away from somebody just scanning the entire network and causing some switch to go crazy when it starts doing neighbor discovery to everything. Now we're gonna talk about a lot of the problems that we encountered through this, and our biggest pain has actually been our hardware, the networking hardware. Again, vendors don't do QA on IPv6, and our particular vendor has been pretty bad. So I won't name names, but they've caused a lot of heartache, and actually I probably would be presenting today about how we're 100% complete instead of where we are, had it not been for this problem. So we started doing v6 internally around April of last year is when we started seeing our first significant bits. It actually kind of corresponded when I came back from paternity leave. And we started seeing randomly hosts, with multi-second latencies. And we didn't know what it was. And we tracked it down to when the network flapped on a host or you restarted the network for some reason. And so we initially suspected it was Linux. We just thought, oh, we're running an old Linux kernel, let's upgrade. Everything we upgraded to wouldn't work. We started making patches. We just couldn't figure it out. And then our networking engineers got involved, and then they said, oh, the packets, the hardware address is not in the hardware table. It's only in the software table of the switch. So it turned out the vendor does a batch update when it does an add or delete to the hardware and software tables. And so it would add and delete the MAC address, basically. And it would think that it was in the hardware table when it was actually deleted from the hardware table. So, and everything ended up being software switched. And like I said, this set us back about 6 months because we had to go through and upgrade every rack in our network. It's not bad enough that the vendor that provided the switch had the problems. It's also the ASIC that caused us some problems, mainly because for more specific prefixes for anything from a 65 to 128, there's only 127 entries available. So it basically forced us to use a 64 for all point-to-point interfaces and for all of our, what we call our route injection in our network. So we actually had to go through and renumber. Luckily, this was a behind-the-scenes thing. It actually happened, well before we started down the path, but it was another one of those hiccups that we ran into. You'd think, okay, I got a v4 session and a v6 session for BGP. Well, it turns out the cluster switches that we had could not handle twice as many BGP sessions. So we ended up having to run everything over a single BGP session. And it just forced yet another change to our configuration. Again, it was something that happened behind the scenes. It didn't affect anything. It was just still work and one of those things that we weren't expecting. This was another great one. You turn on IPv6 in the BGP session to a rack that doesn't have v6 enabled, and the rack switches go down. That was a particularly fun day. And then we had our multi-second latencies return after we've performed all these rack switch upgrades, and they had the hardware vendor had yet another software problem, but this time instead of it being from the rack to the host, it ended up being from the rack to the cluster switch. Luckily, we were able to remediate this as well, just through automation and rebuilding of the configs. And then that same vendor had we started seeing traffic where traffic was well balanced across the multiple links from the rack into the core. Over IPv6, traffic started to be imbalanced, and basically, if BGP comes up before neighbor discovery completes, then that link is dead until you bring down BGP and you end up pinging the next hop and then bringing BGP back up. So we had racks where we had multiple tens of gigabits of capacity on V4, and when we switched it over to V6, we had 10. And we saturated that link pretty quickly. Facebook is a PHP shop. PHP is particularly bad with IPv6, especially since it provides these lovely functions that treat IP addresses as integers. And we had this riddled all through our code. People thought, oh, I'll convert all my IP addresses to integers. Well, that doesn't work in a V6 world. IP addresses are not integers, and they're actually also not strings. So that's yet another problem. PHP also has a lot of inconsistent APIs. Some functions will take an IP address, but it's really expecting an IP address in a URL form, which means IPv6 IPs have to be bracket enclosed. And it doesn't really tell you, because when you're looking at your code in the V4 world, you don't have to bracket enclose anything, even though you don't have like HTTP or some other scheme defined. It still wants it in a URL. String representation of V6 addresses actually hurt us. Early on, we noticed that Java was producing a different zero compressed string than, say, glibc or any of the libcs out there. So, it forced us to actually say, okay, we're going to normalize all of our input and output. And so we instead of zero compressing, we fully expand the addresses, because it's actually something that we know is extremely deterministic, and we don't have to, worry about, we don't have to worry about it's this libc or this application or whatever's doing it. And it forces us, we can accept all inputs, but we then normalize it into something that we, can compare against internally. Regular expressions are also a big pain. It's really easy in V4. It's pretty terrible in V6. Whoever picked colon as the delimiter for IPv6 addresses, I have a huge beef with you. Everybody keys off of host port pairs. They combine them, with simple split and join functions. That doesn't work. Everyone, just assumes you can do that. And then you also have to bracket enclose it. So one of the beauties of our fully expanded address is that if we do have code, instead of doing a split on the first colon, we do a split on the last colon. So it actually, for places that didn't really want to bracket enclose, they just wanted to log an IP address, it doesn't matter for them. Comparing, IPs, even though that these two are the same IP, they're not string equality. So these are the things, that we ran into. We also, for storing addresses, we used to store IPs as integers everywhere, and I just say don't do this. Like it's horrible. Just don't do it. Then people are like, oh, well, let's store strings. And again, why are you gonna waste? If you follow the RFC, you have to do like 43 bytes for a V6 address. If you really want to hold all that storage. So we also don't store anything as strings. I advocate you just store everything in a binary format. We happen to use MySQL to store a lot of things, and we just use, a variable length 16-byte binary, and it works out great. This was yet another problem. glibc had some pretty interesting bug where, if you called getAtterInfo with an IP address, occasionally after a process had been running for a while, it started returning, it doesn't know how to communicate with this family when it was just working just fine. And it was interesting because inside of glibc they had a check, and they would try to allocate a netlink socket. But if it had one error, and it doesn't matter what the error was, it would then just stop communicate. It would stop working for when you pass it an IP address, an IPv6 IP address. So, it wasn't fixed until recently. Luckily, we moved pretty quickly, and so we were able to, just avoid this problem altogether. And it actually forced a lot of people to go to our new runtime a lot, it was a good thing for us internally because it just forced us to change. And then our biggest problem was actually our engineering team. This was actually covered yesterday. People don't teach IPv6. They don't teach what, an AFINet 6 socket is. I don't know how many times I'll see new code where somebody just calls socket directly with AFINet, and internally that code gets usually automatically rejected now through some automation where people can't just commit IPv4 only code. Most people have no idea what getAttr.info is. They don't understand the hints. And they're just, like I said, they're constantly just writing v4 only code because that's what they're taught in school, and they're not taught, that there's this other protocol out there. So we actually have a pretty aggressive solution. We're actually taking v4 away from their development systems starting this summer, and it's going to force them to basically develop their code to work in a v6 environment. And here's my engineer. So, we also had another problem. Some people actually wanted to use Slack. Well, that shows up terrible. It's a great idea, but it's actually pretty bad for your data center deployments. There are times where, we'll change a network card, but we won't change the host, right? So why should its IP address change behind the scenes? So we do a static allocation, and then some people are like, let's encode the v4 address in our v6 address. And I said no. Mainly, you need to think about v6 as a way to get rid of your technical debt. And if you're trying to come up with some fancy scheme so you can know what a host v4 address is from its v6 IP, well, what happens when you don't have any more v4? And now you're going to be stuck with two address allocation schemes. So use those bits for something else. Don't use them for thinking you're going to be saving yourself some time when really you're just going to be adding more technical debt. And we ran into some pretty minor problems with Linux, surprisingly. And there were simple things like it has this routing and neighbor table that it defaults to 4096. Well, we have more than 4096 hosts talking to a single machine. So, once it hits that limit, it is unable to communicate. It's actually worse than that. It'll eventually forget its next hop if you're using router advertisements. So it'll eventually just fall off the network on v6 completely. It also runs garbage collection when there's more than 512 entries in the neighbor table, and we have more than 512 machines talking to a single machine. So what will happen is the kernel will just start spinning in system time, and the machine's latencies go up because it actually does a lot of this in earlier versions of Linux. It does a lot of this in interrupt contexts. So it's it's pretty terrible. And it does things like all the connections have a default TTL of 30 seconds. Well, we have a lot of machines talking to a single machine. It might not see that same machine again for maybe 32 seconds. So then it gets added and deleted. So we had to increase our timeouts internally so things actually just stay, so your routing table is sort of consistent, or your neighbor table. And then there's just interesting things like in the IPv6 world, if you want to dump your routing table, it will scan all the cached entries. So if you have thousands and thousands of machines talking to the machine, it'll take forever. Or there's actually a bug where it'll just print the same routes over and over and over again if you're in a high traffic environment. Running netstat will actually cause the kernel to oops. A lot of these things have been fixed, but these are some of the things that we ran into. This one was particularly interesting. If you restart the network and you're not on a relatively new kernel, and you have things on, say, a dummy interface or on loopback, as soon as you restart the network, those IPs stop responding. It has to do with internal routing. They just didn't rebuild it on network restart. So the only way to get it to work again is to add and remove the address. The funny thing about this is we ran into it, and the bug was actually fixed a week before we ran into it. So it was pretty easy for us to just cherry pick the change and and move on. Try to avoid, like, if a lot of places have disabled IPv6 in their kernels. Try to avoid doing it this way, where you disable it via the module, mainly because it requires a reboot to re-enable it. So we actually did this like 4 or 5 years ago. We actually blacklisted v6 so that it wouldn't load. So for us, we were able to actually load the v6 module across our entire fleet over the span of about 2 weeks, slowly, by just unblacklisting and loading it. And so we didn't have to have any downtime. The only thing we had to do was like restart daemons, and we did that all through automation and remediation. So it was pretty good. Just disable autocomp. It's, like I said, it's pretty bad for your data center deployments. You also just don't want to have, multiple addresses on your machine if you're doing, you don't want to have this Slack address and this static address, because then it's kind of non-deterministic. Well, I mean, it is actually deterministic, but people, if you see a connection to your next machine, it could be coming from the Slack IP, and then you're like, well, why doesn't this host name resolve if you're trying to look it up? One of the other problems we encountered was, do we deploy quad A records internally or not? Basically, because some applications, they're working fine today, and then they get a quad A record, and if they're written properly, when you call get adder info, it returns to you a list of addresses. If you have v6, if you have a quad A record, that v4 host will then try to fall back to v6, but it can't, because it can't connect to it. It doesn't actually know how to talk v6. You get your engineers complain. It's just, don't do it unless you actually need it. We didn't need it because we have our own service discovery framework, and it's only we'll be actually finished with our about 50% of all our hosts will have quad A records by the end of this week, but we are well beyond that in terms of our deployment. And then there's just like applications, like we couldn't do v6 without MySQL 5.6. Well, validating a brand new release of MySQL is actually a pretty heavy engineering effort for us. We were actually on 5.6 now, but it took them a while. Curl's a pretty hostile environment for v6 addresses. They've had some pretty serious bugs with v6 that were only fixed within like the last year. This is actually an interesting thing. We've had, when you go and you tell an engineer, I'm going to enable IPv6 on your application or your backend service, they actually don't know how their application runs in an IPv4 deployment. It's just running and nobody complains to them. So when they actually go and turn on v6, all of a sudden they get interested in what's going on, and they see errors. And then they're like, I see problems with IPv6, let's turn it off. And I was like, but no, we actually break out the errors by IP, protocol. And, almost every time it was not IPv6. And I have a saying, broken code is IP protocol agnostic. So it wasn't all bad. So we'll talk about like a lot of the good stuff that we got. We were able to get rid of a lot of technical debt with v6. We treated it as a completely new deployment. We took the time to get rid of strings and integers in our code base, passing around an IP address class. I'm not going to say we're 100% done there, but once that class was written, it's kind of funny. We didn't even announce it, and then new code just started being used with it. Facebook has a C++ library called Folly that's open source. We're hoping to be including that soon so that other people can benefit from, that bit of code. One of the things that I'm really particularly proud of is our ability to roll out traffic to our backend services from 0 to 100%. You're going to encounter problems, so you need a way to push, instantaneously roll back everything without doing a code push or whatever. And you want to be able to show, okay, I'm going to send 1% of my backend requests over v6, and oh crap, something broke. Okay, let's roll it back and let's go analyze the logs and figure out what's going on. I mean, if you make IPv6 an all or nothing kind of thing, you're going to fail, because that first big outage you have because you turned it on to 100% immediately is going to cause a lot of people to get trigger shy. Whereas, oh, we broke 1% of the requests, or 2 or 5 or whatever, most people are okay with that because, you're not basically impacting everybody. Like if I were to tell you an outage was, due to IPv6, and it caused, significant, public-facing problems, that would be bad, and I probably wouldn't be standing here today. We also have an incredible network engineering team. Behind the scenes for years, they've just been, going through, upgrading our network, making IPv6 native. They converted our entire network infrastructure to layer 3, and, when we launched on World v6 Day, we had native IPv6 everywhere, and I actually wouldn't be standing here today if it weren't for them. I mean, they've actually made my job really easy because bringing up, all of that in an existing infrastructure without taking down, the site is pretty awesome. We also wrote a bunch of APIs to detect whether a host had working IPv6, and this is important for us because we have a lot of machines that we had the rack switch problems, and not all hosts had working IPv6, but we needed to be able to roll out, traffic to, services over IPv6, so it allowed, us to basically have backend services work, and then once v6 was on, the module was loaded. It had a v6 address assigned on its Ethernet interface, but it didn't have a next hop, or it didn't have, it wasn't working. There were just various little things. So we did a lot of that stuff. We made IPv6 a native component in our new service discovery framework, and we forced everyone to migrate to that. Our new service discovery framework solves many problems for us, and we made sure that by using this, you'll get v6 for free. You get the rollout features. You get everything for free internally because of that. So, all services are dual stacked from the beginning. Engineers, if they want to add something to our framework, they could add the IPv4 address today, but the v6 address gets added behind the scenes, and the same thing happens for v6. And then when the time comes for v6 only, it won't add the v4. So it just knows all about that behind the scenes. Facebook is the initial contributor of Thrift, which is our RPC framework. It's actually supported v6 since 2006. It initially was just with a single socket that it allocated a v6 socket and then accepted v4, but we've recently separated those out to make it easier for us to debug. And, we also had a lot of automation. That rack switch problem, which took us 6 months, we would not be done without the automation because everyone said this is something that could never be done. It actually never had been done in the history of Facebook, going through and live upgrading, in the entire data, the entire fleet without, taking something down completely. So, and we also empowered individual teams and engineers to actually go through and upgrade their own, dedicated deployments of machines, which allowed our networking team to focus just on those shared deployments. And I'm happy to say that we actually did finish that rack upgrade because of the automation that we had built. So now let's see where we are today. So I said to you, we had this thing where we didn't have v6 responding on every host. Well, we actually today have 100% of our hosts respond over v6. And I say the ones we care about because we have older legacy clusters which won't be upgraded to IPv6, and those are going away this year, so we just don't care. This is the big one. 75% of our internal traffic is IPv6. That includes everything that's used for advertising. So everything that is built and that we make money off of communicates internally over IPv6. So yesterday people were talking about, oh, I'm afraid, there's bugs. Well, there's a real business being, deployed and depends on the future and the stability of IPv6. We should be at 100% by sometime in Q3, Q4 of this year. So HHVM is our PHP runtime. It's 98% of the traffic in and out. So like I go to Facebook.com, I generate my news feed. All those requests from the PHP runtime, 98% of them go over IPv6. And that should be 100% here probably in the next 4 to 6 weeks. We do a lot of memcache work. I did a lot of that on my early time at Facebook. 100% of that traffic is also IPv6, and that's significant. And as I said, we won't have any more IPv4 plumbed into our network probably within 2 to 3 years. I'll talk about this in the next slide, but basically we won't go through and remove v4 from our existing deployments because we have things like out-of-band management on older hardware that just we're not going to upgrade. We're not going to go through and upgrade those hosts. They will just naturally decline and go away. But what we will be doing is deploying v6 only new clusters going forward. So those existing clusters can still boot over the network on v4, but once they come up, all the internal communication will still be v6. So and we have new v6 showing up daily. That 75% a week and a half ago was 65%. That shows you how quickly we move and how quickly things just happen at Facebook. I actually have engineers asking if they can write IPv6 only code. I actually tell them no, because if we ever want to open source anything, we're not good citizens if this code only works in v6, because realistically not everyone's going to be where we are today. An important thing is, again, people are saying, well, v6, v4, is it faster, is it slower, is it more unstable? We've seen no differences. People talk about externally v6 is faster than v4. Internally, we see them more or less even. Maybe sometimes one is faster than the other, but they flip-flop. But overall, statistically, they're more or less even for us internally. As I said, we have plans for our first v6 only cluster by the end of this year, maybe sooner. And then in 2015, there will be no v4 plumbed to any of our hosts. Going forward. And that's it. Thank you.
So thank you, Paul. I think we'll take questions during the panel.
Okay.
I think we're going to set up the panel. So what I have on the panel is both Paul and Martin. I also have Khalid from Cisco, and then I've asked Professor Hiroshi to come up as well so that he can talk about Sony Corporation. We're going to set up.